Here we are in problem 2 for review for the test. So first things first, finding critical points. So I'm going to run through this as fast as I can. Finding critical points. So we're going to take the partial derivative of our function with respect to x, which would just be 4x cubed minus 4, and then with respect to y, which would be 3y squared. Minus 2y. Now we're going to send them both equal to 0 and solve. So therefore 0 equals 4x cubed minus 4, which gives us x cubed equals 1, which means x equals 1. Why was setting them equal to 0? Well, we want to find maxes, mins, and saddles. So therefore that would give us, if it's equal to 0, that gives us a max or a min. So don't forget to take the derivative first, but there you go. So now, just want to point out this one, much easier if you remember to factor, because now we just get y equals 0 for one answer, and then we get y equals 2/3 for the other answer. So now we just say to ourselves, I have to put my x's with my y's because it's coming from my derivative in the x direction, derivative in the y direction, and I didn't get one of the values by plugging in my x value or plugging in my y value, so they just all get paired up together. So I get one point of x being 1, y being 0, the other one of x being 1, y being 2/3. Now we're just going to go ahead and substitute those back into the original equation, and you'll see that gives you -3, and then when I substitute these values in, I get something absolutely horrific. So that comes out to be -85/27. Let me fix that. But we don't really care because we don't need that number for anything else at this point. Now what we're going to do is see, rephrase, we don't need it for other than just writing the answer, but we don't have to do any math with it. So now what we're going to do is just say, what are these mins, max, saddles? So we're going to go to our second derivatives. We use concavity to check what things are. So now the second derivative of f with respect to x, that would be 12x squared. The second derivative with respect to y, that would be 6y minus 2. And then the derivative with respect to x, then y, well, because there is no interaction term, that would just be 0. So when we use our d-test, that's second derivative with respect to x times second derivative with respect to y minus the second derivative with respect to x, then y, squared, evaluated at whatever point we're trying to test. So I'm going to start off by testing the point 1, 0. So d of 1, 0, when I substitute in 1 for x's, that gives me 12. When I substitute in 0 for y's, that'll leave me with -2. And I can stop right there because I see the concavities do not match. This is concave up, this is concave down, therefore I know it is a saddle point. So therefore this is a saddle. Then for the d-test for the other point, it would be d of 1 2/3. Well, again, it's still the same 12 there, but when I substitute into 2/3 into my second derivative with respect to y, when I sub it into right there, I'm going to end up getting +2. So then -0 squared, but again, we don't need this because it's just 0. So that's going to end up giving me 24. How do we read the d-test? Well, any number that's greater than or equal to 0, we just go back and look at one of the concavities and make our decision. Since this is concave up, we know it is a min. So we can now say we know we have a min for that point. Okay, hope that helped.